Hello everyone, thank you for joining me today in this session. So today in this session we are going to continue from task 3 of this project, malloc and free. So this task here says we should write a function that returns a pointer to a two-dimensional array. We know what a two-dimensional array is, right? We've talked about it when we're talking about pointers. So this is a prototype, and as you can see here, it takes in two parameters, width and what, and height. So each element of the grid should be initialized to 0 because two-dimensional arrays are mostly in grid format, right? So the function should return null on failure if width or height is 0, or negative, return a null. So what this means is that we are going to write a function that returns a pointer to a 2D array. So we are going to create a space for 2D array. And this width here you're seeing here is going to be the width of the array, and this height will be the height of the array. So it means width here is just going to be the number of columns in the array, and height is going to be the number of rows. Let me give you an example. If assuming my width is, let's say width is equals to, let's say 3, and my height is equals to 4, right? So my height is going to be 4. It means I'm going to have 4 rows, isn't it, and 3 columns. So let's say I have 1, 2, these are the element of the array, 3, right? So it's going to be 4, 5, 6, 7, 8, 9, let's say 10, 11, and 12. So this here is what is an array which has how many rows? 4 rows, 1, 2, 3, 4, right? And how many columns? 3 columns. Did you see that? 4 rows, 3 columns, isn't it? So the width here is going to represent the number of columns, and the height is going to represent the number of rows. So let's take note of that. Alright, so what do we need to do first here? And you can see here it says each element of the grid should be initialized to 0. When you look at this, this is a grid, right? This is a grid. Okay, so what do we need to do first? Let's open the file. So 3 alloc grid. So vi paste this. Alright, so as you can see, I have my Betty documented already to avoid time wastage. So let's begin writing the function. So when you look at this here, this is a pointer, right? It's returning a pointer. When you see this, it means what? It's returning a double pointer to what? To an integer. Why are we getting a pointer? Because it is a two-dimensional array that this function is going to return. So that's why we're getting a double pointer here. Do you get it? The first is going to point to the height, and the first is going to point to the width. So we need to take care of that, right? So it means that we know that we need to create a pointer to hold the return value of malloc, right? But in this case, it's going to return what? A double pointer. So I also need a double pointer to hold the return value of malloc, right? And what am I storing in the location that malloc will allocate to me? It's an integer. So I need to say int asterisk double pointer, right? So I'll just call it output, right? That's what I need to do first. So let's pass in this condition which says if width or height is 0 or negative, that is if it is less than or equals to 0, we are going to return null, right? So I will say if width is less than or equals to 0, right? Or height is less than or equals to 0, what should we return? We are going to return a null. Isn't it? That's what the question asks us to do. So what do we need to do next? The next thing is we need to allocate memory now. And this memory we are going to allocate, it's going to allocate memory for the whole array. Okay? It's going to allocate memory for the whole array. And inside the whole array, how many columns do we have? Sorry, how many rows do we have? Because we need to have our rows for us to be able to create the columns. That is the data inside the rows, right? We need to have what? The row. We need to first find the row, and then we'll be able to create the element that will be stored inside the row. And this element is going to form what? The content, or it's going to form the columns of the array, right? So what I'm going to do here is I'll just say output, right, is equals to, I'll call malloc, and then size of what? Size of int. But in this case, I'm going to put asterisk. So why am I using this asterisk? Because this memory I want to allocate here is for what? Is for the rows here. So I'm pointing to the row now. I want memory allocated for the rows. Do you get it? So, and what am I going to put here? This is going to be times what? What is expected to keep track of the row? The height is expected to keep track of the number of rows we have, right? So I'll just say times height. So memory will be allocated for what? For this row, and also this row, and also this row. Memory will be allocated for the rows. Memory will not be allocated for the columns yet. Okay, it will just be allocated for the rows now. Do you get it? So now the next thing is we need to check if malloc fails, right? So if malloc is equals to null, sorry, not malloc, it's supposed to be output. So if output is equals to null, it means malloc fails, right? So I'll just say return a null. Isn't it? That's what should happen, right? So the next thing we need to do is we need to now allocate space for the what? For the columns, right? We need to allocate space for the columns. So for us to allocate space for the columns, we need to loop over each row. So for each row, we need to allocate space for each of the elements inside that row. That will make up the what? The number of columns, right? So here I will need a loop. I will say for I equals to 0, I will declare the variable I later on. So how many rows are we iterating over now? We are iterating height number of rows, right? So this is going to be less than height, isn't it? And then what? I plus plus. So this is what we need to do, right? So the next thing we need to do is what? We need to now allocate memory for each element of the row, right? We need to allocate memory for each element of the row. And how do we do that? We simply need to say output, right, at index I, right? We are allocating memory now for what? For the entire row here. Like I said initially, memory is not allocated for us to store the content of the array of each row, right? But now we are going to allocate memory to store the content of each row. So why am I saying output I? It means output at index I. If I is equals to 0, it means it's going to target index 0 of our array, which is what? Index 0 is going to be this part here, right? Index 1 will be what? This part. Index 2 will be this part. Index 3 will be this part, isn't it? So now it's going to target index 0. That's for the first iteration. So output is equals to what? Malloc, and then this is going to be size of what am I storing inside the row? I'm storing integer values, right? So it's going to be size of int, right? And then times what? Times width, because how many columns am I expected to store inside each row? How many number of characters? Width is going to keep track of the number of characters I'm going to store, or the number of integers, which is going to be the number of columns, right? So that's why this is going to be times width. Do you get it? So the next thing we need to do is we need to check if malloc fails, right? So I now say if output here at index I is equals to null, it means malloc fails, right? So when you look at this, there is something I need to explain here before we proceed. There is no way in the test file here that the function is being freed, right? The function has not been freed in any case here. So we need to free the function, right? So if output at index I is equals to null, it means memory will not be allocated for this particular row, right? Memory will not be allocated because it is null. So if it is null, then I need to free the memory above here. This entire memory need to be freed, because if this first allocation failed for this row, it means there will not be space for the other rows as well, right? So I just need to free the memory that was allocated for me initially. So I'll just say free, and then I will call on output, right? I will free my output. So what if for the first iteration, that is output index 0, memory is allocated to me, right? It is only, let's say, at output index 2 that memory is not allocated, assuming for this row now. Assuming for this row, memory is not allocated. So if memory is not allocated for this, what should happen? It means I will not be able to store all the numbers that I want to store in my array, right? So I need to free the memories previously allocated. So for this, I need a loop, right? I need a loop to free this memory. So let me just say for g equals to 0. I'm starting from index 0 as well. So this is going to be g less than or equals to what? Or equals to height. I want to free these memories here. Memories that have been allocated for me initially before what? Before the null is returned for this particular row. That's what I want to free. So g less than or equals to what? Or equals to height g plus plus, right? So this is going to loop over the entire row, right? And for each iteration, I will just say free output at what? Output at index g. Okay, so this is going to free what? All the memory that is allocated for these different rows, right? If any of the allocation fails, this is what will happen. Okay, if any of the allocation fails, this is what will happen. Do you get it? So what do we need to do next? After all these things, I will just say return a null, right? I will just say return null. So what this means is, after freeing the memories, then we return null. We cannot just return null like this. We need to free the memory so that other programs will be able to use it. Okay? All right. So the next thing we need to do here is what? After the if statement, we need to what? This question here, when you look at it, it says each element of the grid should be initialized to 0. So now what we need to do is to initialize each element of the grid to 0, right? So in this case, I also need another loop, right? So here I will just say for j equals to 0 as well. So what should be the condition? The condition should be j has to be less than what? Has to be less than width, isn't it? Because this is already looping over the height, right? This is looping over the number of rows, right? So now I need to loop over the columns, right? I need to loop over the columns. So this way I'll be able to target all the characters, all the location, or all the indexes of my array. So for j is equals to 0, j less than width, and then I will say j plus plus, right? So here what I'm going to do is simply say output at index I and also index j is equals to what? Is equals to 0. So this is going to store 0 at what? At output index I and also output index j. So assuming I is equals to 0, so this will target what? Output index I, which is what? The row. So this is going to target row 0, which is this, right? This is going to target this row here. Let me just row 0, right? So if row 0 is targeted, so j is also what? 0 for the first iteration. So row 0, column 0 is iterated. Sorry, is targeted. So which one is column 0? This is column 0, right? This one is column 0. So what is at index 0? Sorry, what is at row 0, index 0? It is what? It is 1 in this case. So we are setting it to what? To 0. Do you get it? So if the iteration increment the value of j, if it's increment, it's going to have what? J will now be 1. So it's going to target index 0 or row 0, column 1, right? This is what? Column 1. And it will initialize it with 0. J will be incremented, will initialize it to 0. Then I will now be incremented as well. It will move to this index. J is 0, this is 0. That's how it will keep doing. It will initialize all the grid with what? With the value 0. Do you get it? So the next thing we need to do is simply say return. What we are returning a pointer to the newly allocated space, right? So we are saying return output. Output is the newly allocated memory, right? All right, so let's run Betty here. So Betty 3, okay, trailing white space, line 25, set number, right? So which one is line 25? Okay, this is line 25, right? Yeah, there is a space. So let's run Betty again. Whoa, did I not remove the line? All right, sorry, the space, set number again, line 25. I've removed it already. All right, so I think it's okay now. So let's run Betty again. Yes, so Betty is fine. So let's create the test file to test this function. All right, copy. So vi, this is as squad 3, right? Yeah, so 3 main.c. So paste. All right, so let's compile the program now. Where is the compilation command? Yeah, so paste. Whoa, so what happened here? Okay, I've not declared the variables I and j. I totally forgot about that. So let's do that here. So this is going to be int I and also j. I think this is okay. Okay, so let's compile again. So as you can see, it has been compiled. So let's run the compiled file. So did you see that we are getting the exact output here? Okay, so memories have been allocated to each of these characters, or sorry, integers you are seeing here. And also what? They are initialized to 0. Why are we getting 98 here? Because at this index here, row 0, index 3, row 0, column 0, row 0, column 1, row 0, column 2, row 0, column 3, the value has been set to 98. and for row 3 column 4 the value has been set to 402. That's why you're having something like this. Okay, so don't forget to add commit and push to a GitHub, and then you can run your checks. We are going to stop here. In the next video we are going to continue from task 4 of this project. So thank you very much till we meet in our next session.